Good afternoon, everyone. So, dear students, in our last lecture, we obtained the expression for most safe speed of vehicle along the banked road. Before that, we also obtained the relation for the optimum speed of vehicle on plain curve road. So last article was the maximum, or that is the most safe speed for vehicle on banked road. It was actually V equal to square root of Rg into tan of theta, especially on banked road. We know the definition of banking of road, the angle of banking and so on. Now here one thing must be remembered, that this safe speed, which is equal to Rg square root of Rg tan theta, we cannot drive the vehicle always with this speed. The speed of vehicle on curved road banked at some angle theta cannot be always this much. Sometimes it may greater than this speed and sometimes it may be less than the speed. So here we have to find out the lower and upper speed limit on the banked road. So when we consider this relation V equal to Rg tan of theta, we neglect the effect of friction. But to find the lower and upper speed limit of vehicle, limit of speed on the banked road, we have to consider the effect of friction. How we can consider the effect of friction? There are two parts. Second part, first part was most safe speed that we have obtained initially in last lecture. Now for lower speed limit, the same figure. Again, the vehicle of mass m, it is moving with velocity v on the banked road of radius r, banked at an angle theta. But in this case, we have to consider one extra force. In last case, we consider only two forces acting on the vehicle. That was first weight mg, which is acting vertically in downward direction, and second normal reaction perpendicular to the inclined surface. But in this case, we have to consider a third force in action, and that force is force of friction. So for lower limit of this condition, that is lower speed limit, the centripetal force v square upon r must be less than n sine of theta. For lower speed limit, the centripetal force must be less than n sine of theta. If the centripetal force is less than n sine of theta, it is observed that the friction force between the surface of road and tires of the vehicle is acting parallel to this inclined surface but in upward direction, like this. This is the force of friction, which is acting in upward direction parallel to the surface of road. So that force of friction is also vector quantity, and it can be resolved into two components. First, Fs cos of theta, which is opposite to this n sin theta, the component of normal reaction. And second is F sin theta, which is in upward direction, in the same direction as that of n cos theta. So the force of friction now in action on the banked road for lower speed limit, the force of friction is acting in upward direction parallel to the inclined surface. It is resolved into two components, F cos theta opposite to n sin theta, and F sin of theta, which is in the direction of n cos theta. So we can write now the relations for lower speed limit as that n sin theta and f cos theta are in opposite direction. So centripetal force is provided by, therefore this n sin of theta minus f s cos of theta provides v square upon r, necessary centripetal force. Consider this as equation number 1. Again we can consider here velocity v1. So this is first condition, n sin theta which is towards the center, f cos theta which is in outward direction. So net force acting on the vehicle is n sin theta minus f cos theta, which provides necessary centripetal force for the circular motion. And second part, this weight mg is balanced by not only n cos theta, in addition to n cos theta there is a component of frictional force F sin theta. So we can write here n cos of theta plus Fs into sin of theta is equal to mg. Call this as equation number 2. So now these are the two relations for lower speed limit of vehicle on banked road. Now using this equation 1 and 2, divide equation 1 by 2. So we can write here now n sin of theta minus Fs cos of theta divided by this n cos of theta plus Fs sin of theta is equal to m v1 square upon r into 1 by mg. It is clear that on right side m get cancelled. On left side divide numerator and denominator by n cos of theta. So see here carefully, this n sin of theta divided by n cos of theta minus here Fs cos of theta divided by n cos theta. Again for denominator term n cos of theta divided by n cos of theta here plus Fs sin of theta divided by n cos of theta equal to, the remaining part is m get cancelled, it is v1 square divided by r into g. See here carefully, n get cancelled, sin theta upon cos theta is, therefore this is tan of theta minus, here we can write Fs divided by n into cos theta get cancelled, plus n cos theta get cancelled, here is only 1, plus again Fs by n. What about sin theta upon cos theta? Yes, it is tan of theta equal to v1 square upon rg. But we know in case of friction, but force of friction is equal to mu s into n. Therefore this mu s can be written as Fs by n. So instead of Fs by n we can write mu s. So finally here we can write this tan of theta minus mu s divided by 1 plus mu s into tan of theta equal to v1 square upon rg. And finally we can write this relation as, therefore v1 is equal to square root of, see here carefully, this rg go to this side, so rg into tan of theta minus mu s total divided by 1 plus mu s into tan of theta. So this is the lower speed limit of vehicle on the banked road with force of friction in action. For the safe speed limit, we consider that force of friction is negligible, but the lower speed limit and upper speed limit cannot be considered without the role of force of friction. So here we use the role of force of friction and obtain relation for minimum speed limit. If here coefficient of static friction is equal to tan of theta, if you put here mu s is equal to tan of theta, then this V1, its minimum becomes 0. जर tan of theta equal to coefficient of friction झाला, म्हणजे अँगल खूप लहान असेल त्यावेळेस, तर ही स्पीड होते मिनिमम. म्हणजेच त्याला आपण डायरेक्ट लिहू शकतो आता एक्सप्रेशन फॉर मिनिमम स्पीड. And here is mu s equal to tan theta. If we put here mu s equal to tan of theta, then V minimum becomes equal to 0. So 0 into anything 0 divided by anything also 0. So you can write this as lower speed limit of vehicle on banked road like this. Now we have to obtain the upper speed limit. This was lower speed limit. Now last, upper speed limit. To obtain the upper speed limit of vehicle, consider the same figure here. Here again, for vehicle of mass m, its weight is acting vertically in downward direction, normal reaction perpendicular to inclined surface, resolution of normal reaction upper component n cos theta, horizontal component n sin theta. In addition to this, for maximum safety speed, that is, now in this case, this mv square upon r must be greater than n sin of theta. Here you can consider 1, here you can consider this as 2. So centripetal force must be greater than the n cos theta, sorry, n sin of theta. In this case, it is observed that the force of friction is acting parallel to the inclined surface but in downward direction like this. So this force of friction is also resolved into two components. Horizontal component Fs cos theta, which is in the same direction of n sin theta, and vertical component Fs sin theta, which is again in the same direction of weight mg of the car, mg of the vehicle. So in this case, we can write two equations similar to equation 1 and 2 as, see here, this n sin theta and Fs cos theta are in the same direction towards the center of circle. They must provide centripetal force. Therefore, we can write n sin of theta plus Fs cos of theta equal to mv square, consider this as 2 divided by r, and similarly call this as equation number 1, and similarly this mg plus Fs sin theta equal to n cos theta, means we can write this as n cos of theta minus Fs sin of theta equal to mg. Call this equation number 2. So again, using equation 1 and 2, divide equation 1 by 2. See here carefully, dividing equation 1 by 2, we can write here n sin of theta plus Fs cos of theta divided by here n cos of theta minus Fs sin of theta is equal to here m v2 square divided by r into 1 by mg. Here m get cancel. Again divide both sides by equation that is numerator and denominator by n cos of theta. So here also n sin of theta divided by n cos of theta plus s cos of theta divided by n cos of theta for denominator term n cos of theta divided by again n cos theta last minus s by n. Here it is sin of theta divided by cos of theta. What remains on right side? Here only v2 square divided by r into g. See here carefully again. N get cancelled, sin theta upon cos theta is again tan of theta. Here f s upon n, as usual it is mu s. Here plus mu s into cos theta get cancelled. Last, here n cos theta upon n cos theta is 1. Here sin is minus. Again fs by n is coefficient of static friction mu s. Sin theta upon cos theta tan of theta. Here it is v2 square upon rg. But this v2 square is v maximum. So we can write therefore v maximum is equal to square root of what remains in square root is rg on this side in bracket tan of theta plus mu s divided by 1 minus mu s into tan of theta. So this is the required expression for upper speed limit. In upper speed limit, if we consider this mu s, value of mu s as 1 and we consider tan theta equal to 1, that is angle theta greater than or equal to 45 degree. If you put here tan of theta equal to 45 degree and mu s equal to 1, what happens? Tan 45 equal to 1, mu s equal to mu maximum, coefficient of static friction, maximum coefficient of static friction is equal to 1. So mu s equal to 1. What is this total? 1. 1 minus 1, 0. Anything by 0, it becomes infinity. So v maximum can be infinity. Consider this as example of well of death. So in which such situations can be considered. But in this case, mu s equal to tan of theta, coefficient of friction equal to angle which is very very small, then we get v minimum equal to 0. It is possible for very rough surface of road. जर surface खूप रफ असेल, खूप मोठे दगड गोटे वगैरे त्या रोडवर असतील तर व्हेकल काय होईल, चालता चालता थांबू शकतं. म्हणजे त्याची स्पीड काय झाली, 0 झाली. आणि हे जर आपण जस्ट लाईक वेल ऑफ डेथ घेतली, मौत का कुवा घेतला, त्याच्यात सरफेस हॉरिझॉन्टल असतो, स्पीड मॅक्सिमम होऊ शकते आणि ही अशा पद्धतीने होऊ शकते. आता हे समजण्यासाठी ही एक छोटीशी फिगर खाली तुम्हाला लक्षात घ्यावी लागेल थोडंसं, कारण हे कंपोनंट इथे टाकलेले लक्षात येत नाही. त्यासाठी काय करू आपण, हे बघा फिगरमध्ये हा पहिला राईटचा पार्ट, अगोदरचा पार्ट सोडून द्या. या फिगरमध्ये n cos थीटा वर गेलेला, त्याच्यासोबत त्याचा कंपोनंट आपण इथंच दाखवला. फोर्स ऑफ फ्रिक्शन इथे जर दाखवलं तर फोर्स ऑफ फ्रिक्शनचे दोन भाग, एक आहे fs cos थीटा राईट साईडला आणि वरच एक असेल इथं fs sin of theta also in upward direction. So these two forces are in the same direction and here fs cos theta is in this direction. So fs cos theta and fs cos theta in this n sin theta in this case are exactly opposite. And same condition जर आपण इथं त्याच्यासाठी घेतली लोअर लिमिट कंडिशन साठी, लोअर लिमिट साठी, तर त्यावेळेस परत हेच पार्ट आपले थोडेसे वेगळे होऊ शकतात. ही लोअर लिमिट साठी, ही अप्पर लिमिट साठी. अप्पर लिमिट साठी कंडिशन घेतली तर काय होऊ शकते, ही अशा पद्धतीने. हे फोर्स ऑफ फ्रिक्शन इकडे दाखवलं, त्याचा fs cos थीटा या डायरेक्शनला आणि mg च्या डायरेक्शनलाच आहे. हा म्हणजे तुम्ही इंडिव्हिज्युअल जर एक एक घेतलं तर तुमचं रिलेशन कशा पद्धतीने होऊ शकतं. सो कंबाईन सेंट्रिपिटल फोर्स आणि वेट mg ह्याला दोन्ही वेळेस अशा पद्धतीने बॅलन्स करायचं आणि हे इक्वेशन तुम्ही आणू शकता. सो बँकिंग ऑफ रोड, अँगल ऑफ बँकिंग, त्याच्यात दोन कंडिशन्स टाकल्या, अप्पर स्पीड लिमिट, लोअर स्पीड लिमिट, त्यांच्यासाठीच्या त्या फिगर्स सेपरेट काढलेल्या आणि कंबाईन एक तुम्ही समजून घेऊ शकता, काढायची असेल त्याला सेपरेट करू शकता असं दोन फिगर वेगवेगळे. पण आपण आता पुस्तकात दिल्याप्रमाणे इथेच दाखवलं ते कंपोनंट रिझोल्युशन वगैरे. तर ही झाली तुमची लोअर स्पीड लिमिट इक्वल टू व्ही मिनिमम आणि ही झाली अप्पर स्पीड लिमिट जी की वरची स्पीड असू शकते, इन्फिनिटीपर्यंत जाऊ शकते. ह्याही स्पीड फार क्वचित वेळा येत असतात. ह्या स्पीड काही फार नेहमी येतात असं नाही. मॅक्झिमम वेळा कोणती असते, कुणाला कसं वाटतं सुरक्षित जावं, टर्नवर कुणीही हळू जातं, जे खूप जोरात जातात ते कायमचे जातात, त्यांना 4 लोक लागतात उचलून न्यायला. आपल्याला ती स्पीड माहिती असावी फक्त, कारण जाणीव ठेवायची की हे योग्य नाही. त्याच्यासाठी ही मिनिमम स्पीड इतक्याही हळू कोणी जाणार नाही, ही इन्फिनिटीपर्यंत जाणार, एवढ्या नाही कोणी जाणार नाही. सुरक्षित स्पीड कोणती आहे, व्ही इक्वल टू स्क्वेअर रूट ऑफ RG टॅन ऑफ थीटा. हे झालं बँकिंग ऑफ रोड. दुसरं महत्त्वाचं ॲप्लिकेशन सर्क्युलर मोशनचं. तिसरं जे ॲप्लिकेशन आहे ते आपण नंतरच्या तासामध्ये बघू. ठीक आहे.